right, we got a car accelerating from 20 meters per second to rest in 10 seconds. I put acceleration in quotes because we're actually slowing down, and I know that that's something that people... It's not intuitive, but that's how we say it in physics. Acceleration is speeding up or slowing down. It's also changing direction, but we'll worry about that later. Now, we got 10 seconds of time to fill up. So on your graphs, I want to see you fill up the whole graph. So we got like 2, 4, 6, 8, 10 seconds. And then here we got 20, 16, 12, 8, 4. So I'd label it like this. So, you know, I'd even say here 4, 12, 20, like that. So we start at 20. We end up at 10. And what we need to do is just kind of draw a line that connects that like that. I do this with a ruler on the exam. Now we want to get the acceleration of the car. There's two ways we could do this. We could do v equals at plus v naught. We could say, well, 0 equals a times 10 plus 20. And again, if I'm going to follow the recipe here, I've got x, x naught, v, v naught, a, and t. Don't know a, I know t is 10 seconds. X, I don't know. I know x naught is 0. V is going to be 0. V initial is going to be 20. We can plug that in there. And so what we end up getting is that a is negative 2 meters per second squared. Another way to do this is the acceleration is the slope of this velocity graph. So we can say that this is one point and this is another point. And so this is 10 seconds and 0. This is 0 seconds and 20. And so I can do y2 minus y1 over x2 minus x1, which will be 0 minus 20 over 10 minus 0. And that's also going to give me negative 2 meters per second squared. Now let's get how far the car travels in these 10 seconds. There's a lot of equations we could use. So v equals at plus v naught we already used. So let's use the next equation of the series. V squared equals v naught squared plus 2 times a times x minus x naught. And we'll plug in our numbers using all the stuff here. So I have v squared is 0 equals 20 squared plus 2 times negative 2 times x minus 0. And so I end up getting that x, when I simplify this, is going to work out to be 100 meters. And that's all you have to explain. Now, how fast is the car going after 3 seconds? We could use the linear model and say, well, v equals at plus v naught. And we know that v naught, so v is going to be negative 2 times 3 plus 20, which ends up being 14 meters per second. I suppose we could also read it off the graph, which if we were to do that, you could do the math or you could read it off the graph. Either one works just fine. So this is page 4. And we will continue in the next video.